It's absolutely unsound. It's going to detonate. No giving me won't be an astonishing opportunity to go for that. The thing is, it very well may be tomorrow. It very well may be during this transmission. What's more, it would gleam like a resulting sun over the James Webb Telescope. Recently, it has recognized an astonishing 250% increase in the splendor of dreadful Crawley Jew, the red star found at the shoulder of the Orion constellation. This capricious behavior has ignited energy for a captivating feature. Some suggest the unforeseen expansion in splendor could show that Betelgeuse is planning to go supernova, yet the particular timing remains questionable. Specialists gauge it could happen before long. Join us as we investigate the depths of space and disentangle the secrets surrounding this heavenly Goliath. Bug juice can potentially reshape how we understand the universe. Regardless of its name not being well known, you've probably noticed its splendor, a dazzling rosy shine transmitting at the shoulder of Orion, a noticeable star group. Bug juice's size is faltering. Whenever set at the center of our planetary system, its outer surface would extend past Jupiter's orbit. This beast star, easily visible, continues to charm us. Unlike most stars, insect juice varies in splendor over time because of its vicinity to our system, known as a semi-regular variable star. Its splendor changes occasionally, indicating a potential catastrophic breakdown in a cosmic explosion. As of late, bug juice has become significantly more dazzling due to sensational changes in brightness. These changes include a significant flood on May 20, 2023, when researchers took note of a bewildering 142% increment in splendor, followed by a later update showing a 150% expansion. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse currently ranks as the 7th most brilliant star in the night sky, climbing 3 spots from its usual 10th spot. From the southern hemisphere, scarab juice shines brightly in the evening sky, easily visible at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, underlines insect juice's significance. It offers a captivating opportunity to study the final stage of a massive star's life, providing critical insights into the behavior of red giants before they detonate as supernovae. When bug juice eventually detonates, it could become incredibly bright for about 7 days, possibly creating shadows at night. This prospect has both amateur stargazers and expert astronomers eagerly anticipating the event. Heidi Morris, a researcher at Los Alamos National Laboratory and president of the Padaro Space Scientists and Cosmology Club, highlights the enduring interest in Betelgeuse's brightness changes, a phenomenon long overlooked by other cultures. Currently, Betelgeuse's brightness cycle lasts about 130 days, much shorter than its usual 400-day cycle. These rapid changes offer astronomers a unique opportunity to study this celestial phenomenon in detail, uncovering more about the last stages of a star's life. The strange behavior of Betelgeuse began in 2019 when it violently ejected part of its outer atmosphere. These changes in brightness are exceptional for Betelgeuse, igniting speculation about whether it will soon explode into a supernova. According to a paper by Dupree and other researchers from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its normal 400-day brightness cycle, as its light and outward velocity behavior have changed. Despite its erratic behavior, Betelgeuse remains a massive red supergiant star going through the final stages of rapid evolution. As it drains its fuel, the core will eventually collapse under its immense mass, resulting in a colossal explosion that could potentially darken entire galaxies. The timing of this explosion remains uncertain, as explained by Dr. Doc, a professor of astronomy at the University of Portsmouth. Predicting astronomical explosion events is challenging due to the limited historical data and the complexity of stellar evolution. Insect juice is currently undergoing fusion processes, constantly evolving through elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon at its core, a process that takes millions of years. Ultimately, it will progress to fuse heavier elements until it can no longer sustain fusion reactions, leading to gravitational collapse and possibly forming a black hole or neutron star. While some hypothesize about scarab juice's looming explosion, Historical records show that it has been growing red over the past few years, suggesting that it may take considerable time before it goes supernova. NASA estimates that Betelgeuse isn't expected to explode for another 100,000 years, offering comfort that its blast is unlikely to happen within our lifetimes. Despite the uncertainties in Betelgeuse's behavior, its changes continue to captivate researchers and inspire advances in our understanding of stellar evolution. Dr. Sarah Webb reminds us to stay open to all possibilities, even as we acknowledge that the probability of seeing Betelgeuse's explosion in our lifetimes is slim. Tracking its changes may lead to further scientific breakthroughs, allowing us to keep hope alive for new discoveries in the universe, remembering that it's significant. Our observations of Betelgeuse are essentially glimpses into the past. The light we see from the star is over 600 years old, meaning Betelgeuse may have already exploded, and we wouldn't yet know it. While this possibility exists, it remains uncertain. History has shown that our assumptions in space science can be challenged. Before 1987, astronomers believed that only red supergiants could go supernova. However, in that year, a massive blue star in another galaxy detonated, shocking the scientific community. There is still much to learn, and surprises may lie ahead. Observing Betelgeuse and other massive stars allows us to expand our understanding of celestial phenomena. No matter the lack of a looming explosion, Betelgeuse's ongoing behavior remains captivating. Its changes, both dimming and brightening, reveal fascinating physics. The fact that stars evolve on human timescales is remarkable. While Betelgeuse is currently much brighter than expected due to its irregular multi-day cycle, there is hope it will eventually return to this cycle. However, later observations suggest that Betelgeuse may be in its final stages, changing around the end of its core carbon-burning cycle. This stage involves the transformation of carbon into heavier elements like oxygen and magnesium. If so, researchers expect a core collapse, leading to a supernova that could happen within a few years. Nevertheless, the exact stage of Betelgeuse's evolution remains challenging to determine, and uncertainties persist. The chance of witnessing Betelgeuse's explosion remains unclear, as the carbon-burning phase can last up to 1,000 years, and the study suggesting an impending impact has yet to be accepted for publication. Nonetheless, the potential for Betelgeuse to become a supernova is exciting. It would be a rare event visible even during the day for several days. When the explosion finally occurs, the early signs of the stellar explosion will be subtle but undeniable, with neutrinos sweeping across Earth as high-energy photons escape from the expanding cloud of cosmic debris. Betelgeuse will gradually grow brighter in the night sky, perhaps reaching peak brightness 10,000 to 100,000 times its normal brightness within weeks. This event will astonish anyone lucky enough to witness it, marking a crucial point in time in cosmic history. The remnants of Betelgeuse's explosion could be as bright as a quarter or half of a full moon, packed into a single point of light. Incredibly, this brightness would be visible during the daytime, creating dramatic shadows at night. Estimates suggest that Betelgeuse could become 15 to 100 times brighter than Venus, currently the second brightest object in the evening sky. The display of Betelgeuse's explosion would last for at least 100 days, captivating space enthusiasts and offering a unique opportunity to observe the aftermath up close. Fortunately, Betelgeuse's supernova would pose no threat to humanity, as it is still far away. Telescopes and optical instruments would allow us to observe the event without harm. Nevertheless, such a spectacular event would not go unnoticed. Supernovae are often interpreted as ominous signs, and Betelgeuse's demise could provoke intriguing reactions. Overall, astronomers believe it could indeed reignite widespread interest in stargazing, awakening people to the wonders of the universe. Betelgeuse does not appear to be the only red supergiant in our galaxy. Others, like Edi Carni, could explode before it does. In fact, our Milky Way should experience a supernova about once every 30 years, but we haven't seen one in the last 400 years. However, we've observed the remnants of past explosions, indicating that we're overdue for a significant celestial event. It's only a matter of time before the next star goes supernova, and the universe takes notice. Betelgeuse's history is rich with notable events, including the dramatic dimming in the fall of 2019. This sudden drop in brightness baffled astronomers and sparked speculation about its potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the cause of its dimming remained a mystery until further observations provided insights into the phenomenon. Skywatchers can easily spot scarab juice from their homes, making it an accessible astronomical object to engage with. If a supernova occurs, it would undoubtedly provide an incredible celestial display. As we continue to monitor bug juice, the star remains a focal point of interest for both professional astronomers and amateur skywatchers alike. The ongoing changes in its brightness offer fascinating opportunities to study the cycles occurring within a dying star. With advanced technology, researchers can now examine Betelgeuse's behavior with unprecedented precision. Instruments like the James Webb Space Telescope, alongside ground-based observatories, are uncovering more secrets about this celestial giant. The study of supernovae, like the one Betelgeuse may ultimately become, has far-reaching implications beyond understanding the final stages of a star's life. These explosions play a critical role in the formation of elements heavier than iron, which are essential for the creation of planets, life, and the very universe we live in. In many ways, the death of stars like Betelgeuse contributes to the building blocks of the universe, enabling new stars and planets to form from the remnants of their exploded cores. Should Betelgeuse go supernova during our lifetime, it would offer an exceptional and breathtaking opportunity to witness such an event up close. For those lucky enough to observe it, it would be a once-in-a-lifetime spectacle. The light from the explosion would temporarily surpass all other stars, becoming a prominent feature in our sky as space experts rush to capture the data. The event would fuel further advancements in space exploration, enabling more research into stellar evolution, cosmic explosions, and the mysteries of the universe. Regardless of when it occurs, Betelgeuse's potential explosion will be a critical event for astronomy, expanding our understanding of star death and the life cycles of massive stars. The spectacle may also inspire future generations of astronomers, sparking an interest in the universe and encouraging people to look up in awe at the vast cosmos. As researchers continue to observe Betelgeuse's behavior, the mysteries surrounding its life cycle and impending explosion continue to spark interest across the scientific community. One of the most captivating aspects of this star is its volatility. While many stars display regular patterns of brightness, insect juice is anything but typical. The changes in its light output are not merely due to its normal fluctuation but also the violent activity occurring in its outer layers. These eruptions, which expel material from the star's surface, are a sign of its instability and add an additional layer of interest to its potential for becoming a supernova. Betelgeuse, formerly known as Betelgeuse, is one of the most famous stars in our night sky. Its peculiar behavior has captivated scientists and stargazers alike, leading to ongoing studies that aim to uncover the ultimate fate of this colossal red supergiant. Though its potential to explode as a supernova may seem like a distant event, Betelgeuse's unpredictability has made it a unique subject of research. In fact, the star's distinct behavior offers a rare glimpse into the life cycle of massive stars, providing valuable insights into processes that are otherwise hidden from view. One of the most significant features of Betelgeuse is its location in the Orion constellation. It marks the left shoulder of the hunter in this recognizable star pattern, making it relatively easy to spot with the naked eye. This close proximity to Earth, about 700 light-years away, gives scientists a rare opportunity to study a dying star in detail. While this distance is vast by human standards, it's relatively close on a cosmic scale, allowing us to observe its dramatic fluctuations in brightness more closely than most stars. These fluctuations are a hallmark of Betelgeuse's status as a semi-regular variable star. Its light output varies over time, with periods of dramatic dimming and sudden increases in brightness. This type of behavior is not uncommon among red supergiants, but Betelgeuse's erratic shifts have drawn particular attention. Unlike other stars that have more predictable brightness patterns, Betelgeuse's inconsistencies suggest that something much more profound is occurring within the star's core. Astrophysicists have long speculated about the cause of these fluctuations. Some scientists believe that the star's instability is a sign of an imminent supernova, while others point to the possibility of internal processes like magnetic fields or mass ejections causing the irregularities. Regardless of the precise cause, the unpredictability of Betelgeuse's behavior continues to intrigue researchers. Every new fluctuation in its brightness offers fresh data that could bring us closer to understanding how massive stars evolve before their explosive deaths.
Interestingly, despite these unusual fluctuations, Betelgeuse's eventual supernova remains a topic of debate. While some researchers argue that the star could explode within the next few thousand years, others suggest that the event could be much further off. In fact, some astronomers predict that Betelgeuse may continue its erratic behavior for up to 100,000 years before it goes supernova. This uncertainty stems from the fact that predicting the death of stars, particularly ones as massive and unpredictable as Betelgeuse, is a complex and challenging task. Moreover, the explosion of Betelgeuse could have far-reaching consequences for the study of stellar death. A supernova in our galaxy, especially one as close as Betelgeuse, would offer astronomers a once-in-a-lifetime opportunity to observe the death of a star in unprecedented detail. Such an event would not only allow for a deeper understanding of how stars like Betelgeuse evolve, but also shed light on the broader processes that govern the life cycle of the universe itself. Finally, the mystery surrounding Betelgeuse has the potential to spark renewed interest in space exploration. As scientists continue to monitor the star's fluctuations, the public's fascination with this celestial wonder will likely continue to grow. The prospect of witnessing such a rare and awe-inspiring event could reignite a global fascination with astronomy, inspiring future generations of scientists and space enthusiasts to continue exploring the vast unknown. Whether Betelgeuse explodes in our lifetimes or not, the star's ongoing mysteries will undoubtedly continue to captivate both researchers and the general public alike.